Hello and welcome to Starfish Maths. My name's Sarah and today I'm going to continue with a bit more integration. Today's video is going to build on the first integration video I did, so make sure you check that out first and are really familiar with basic integration. We're going to be looking today at using the chain rule in reverse. So again, you need to make sure you can use the chain rule confidently. Check out that video as well. We'll also look at using a little bit of trig and exponentials and logs. Integration can be a really difficult, big topic because there's so many different kinds of integrals and ways to integrate. So I'm just going to blast through 8 different questions today using different kinds of examples. As ever, do grab pen and paper, work through this at your own pace, pausing, fast forwarding and rewind as you please. I hope this is helpful. Let's get started. Okay, let's start today with this example here. We've got a function we're trying to integrate and it's a function of a function, so this is a kind of chain rule in reverse. And remember, with the chain rule you differentiate the outside and then you multiply by the derivative of the inner function. When we integrate the outside and then instead of timesing by the derivative, because we're doing the opposite and going backwards, we'll divide by the derivative. So we're going to integrate the outside and then we're not integrating the middle, we're still differentiating it. So even though we're integrating, there is going to be some differentiating involved. Let's have a go. We'll start off by integrating the outside. So we add 1 to the power and divide by it. So we're just going to keep that there, not change a thing just yet. Add 1 to the power and then divide by it. And that 2 is just going to sit happily at the beginning as well. Now the derivative of the inner function will be just 4 and we need to divide by that as well. So I'm going to put the 4 down with the 3, multiplying together to get 12. This is indefinite integration, so we'll need a plus c, and then our 2 over 12 will just simplify to 1 over 6. And that's it. So integrating the outside and dividing by the derivative of the middle. Okay, second question now. Again, we're going to integrate the outer function, that's the side bit, and then we're going to divide by the inner function. So first of all, integrating sine, we get minus cos. And I'm just going to keep the 6 at the front there as well. So, and that stuff is unchanged. And then we're going to divide by the derivative of the inner function, so that would be 3. And not forgetting plus c, of course, as always. 6 divided by 3, we can simplify that to 2. Okay, third question. This time we're doing an exponential function. I hope you remember from another video that when you differentiate e to a function, you'll be multiplying by the derivative of that function. But again here we're going to divide by the derivative of the function instead. So let's keep that unchanged and divide by the derivative of the function, so that's 2x plus c, and that will all simplify to 4. Great. And remember too, you can always have a go at integrating something and then check that it's correct by differentiating that and see if you get that expression there. Okay, this one looks complicated, but it's just the chain rule again, reverse chain rule. And the way to spot that we're doing a reverse chain rule is just when you've got stuff that's multiplying with each other, but that looks like it might be the derivative of that. And it does, because when you differentiate an x cubed, you would get an x squared sort of thing. So you're just looking out for this kind of pattern when you've got a derivative of a function multiplying with each other. So that's how to spot this kind of integration. And as you do more practice and more examples, you will get better at spotting these as well. So same as before, we're going to integrate the outside and then divide by the derivative of the middle. So keeping that the same, and we're going to integrate by raising the power by 1 and dividing by it. I'm just putting the 5 there because we've got more stuff to divide by. I'll put a little multiply sign. So the derivative of the inner here will be 6x squared. So we're dividing by both the 5 from there and the derivative of the middle. So on the bottom, all of that is 30x squared, and that will all simplify to just a half. And I mustn't forget plus c. Nice one, well done if you're getting this. Okay, number 5. This one is looking pretty fruity. Let's bring that top up and write it as a power, so we can see what we've got. Right, so we're integrating the outer and dividing by the derivative of the middle. So raising that by 1, keeping this the same. And we're going to divide by the power, and we're also going to divide by the derivative, which is 4x plus c. Alright, let's simplify this up. So half of 4 is 2, 6 divided by 2 is 3, and the x's cancel, so that all simplifies down to 3. Nice! Okay, we need some more trig. Let's have a look at this one. This is a really good example actually of when to spot that it's a reverse chain rule question. We've got stuff multiplying, but notice that that's the derivative of cos. So it is the derivative of the inner function. It's worth practicing a few of these so you can spot that. So the outer function is that you're squaring something, and the inner function is the cos. So the 6 sine x is going to stay there at the beginning. We're going to integrate the fact that we're squaring something, so that power will raise by 1 to be cubed. We're going to divide by the power of 3, and we're also going to divide by the derivative of the inner function. So the derivative of cos is minus sine, so I'll put a minus at the front. Sine. So dividing by that, so they cancel and we're left with a minus 2. Not forgetting plus c. Okay, these last 2 examples are going to be log examples. And again, it's just about recognising the structure and getting used to it, doing some practice on these kind of questions. Remember that the derivative of ln of a function goes to the derivative on the top over the original function. So recognise that that's the structure we've got here. The derivative, or something like the derivative, is on the top of the function. So anytime you've got a fraction where the top is the derivative of the bottom, it's a log kind of integration. So integrating this, we know it's going to be log, and when we integrate to get log, we put a modulus around the log bit. So it's going to be a log of the bottom. And just like the examples we've done before, we're going to divide by the derivative of that inner function. So I'll leave the top there at the beginning and divide by the derivative of the inner. So that's going to be 8x squared. So that's going to be 8x cubed. And that cancels to being a half. Great, let's do one more of those to finish. Okay, last question. And again here we're recognising that the top is the derivative of the bottom. So it's going to be a log ln of that denominator. So we'll put that in the modular signs. Okay, I'll write the numerator at the front here, and we're going to divide by the derivative of that inner function. So the derivative is going to be, we need to use the chain rule here, so it's going to be cos of 2x multiplying by that 2. So we've got chain rule within chain rule. Hope that makes sense. Don't forget the plus c, all of this will simplify down. Nice one. I hope this video was helpful, and I hope I've shown you that there are loads of different kinds of examples to practice, so do keep practicing. I hope that gave you a flavour for all the different sorts of things. I'm going to do some more videos on integration, including integration by parts and integration by substitution. I'll also do another video on more integrating trig functions, because they can be quite tricky. And then I'll wrap up the series of integration with a mixture of different questions. So hope that was helpful, keep practicing and have fun. Thank you for watching.